So in this video, we're going to learn how to draw the atomic diagram for any elements. So we now already know that for each one of the element here, we can draw the atomic structure of it. For example, hydrogen would have one proton. Excuse me. Hydrogen, you would draw a nucleus using a little circle and a one proton represented by a plus symbol. And there's an orbit outside. On the orbit, there's one electron. Okay, so this is basically the atomic diagram of hydrogen. For helium, you would have two protons and two neutrons, and outside orbits you would have two electrons. So this is the atomic diagram of helium. So basically, the atomic diagram shows you what's the atomic structure of the specific elements. Now, the biggest question is, we already know how to figure out the number of protons, neutrons, and electrons, that kind of thing. But the biggest question here we haven't learned yet is, how do we know how many orbits or how many layers this kind of circle we have, and also how many dots or how many electrons we should put on circle. So all of the elements follows the same rule, okay, which is very simple. I'm going to give you one picture shows you what it looks like. Now, when you draw the atomic diagram, we all know that we'll use a little circle representing the nucleus. We can use a plus symbol. Depending on how many you have, okay, you can write a number before after indicating the number of protons, and use a little circle representing neutrons indicating zero charge. Now the orbits, okay, that's what we're most interested in, is the electron distribution. Now usually when you have multiple layers of electrons, we will use partial circle. I mean, there's nothing wrong if you want to draw a complete circle like what we did with the hydrogen helium, okay, but when you have more than one layers, it will be so much easier if you just draw partial layers like this, okay. So we don't redraw the rest of the circle. Now, when you have electrons on the circle, on each layers, okay, on each layer of electrons, we use a lowercase e and negative symbol. E stands for electron, negative symbol representing it carries negative charge, okay. And there's a number, use a number in front indicating the capacity or how many electrons on this circle. So on the first orbit, okay, we're going from inner layer to outer layer, okay, we're going in this order. Okay, we number these layers to be layer 1, layer 2, layer 3, and layer 4. Okay, now on the first layer, okay, it has the full capacity. Now be careful, what I'm trying to say is full capacity means it doesn't have to be completely filled. Like hydrogen has only one electron, okay. Now the full capacity of the first layer is 2 electrons. Okay, the full capacity of the second layer is 8 electrons. Full capacity of the third layer is going to be 8 electrons. And the full capacity of fourth layer has more than 8 electrons, but we're not going that far. We're going to stop at 2 electrons. So you can see in total we're looking at up to 2 plus 8 plus 8 plus 2 equals to 20 electrons. So in other words, we ought to be able to draw the atomic diagram up to 20 electrons. Now since we know that number of electrons equals to number of protons when they are neutral, okay, so we can, which is also the atomic number. So we can see the atomic number, which you can find on top of each block on the periodic table. As a matter of fact, all of the elements on the periodic table are being arranged in the order of atomic number from left to right, and then going through one row and then change from left to right again to the next row. Okay, you can see the numbers going up from left to right and then change it to the next row. So up to 20 electrons, which get basically from hydrogen all the way up to calcium. Okay, for these number 1 to number 20, we need to be able to draw atomic diagram. Okay, we're going to use a few examples to show you how do we do this. Okay, let's say we want to draw atomic diagram for sodium, which has a symbol of Na. Okay, In the period table, you can see sodium is number 11. Let's enlarge a little bit. Number 11 here has the mass number 22.999, which is basically 23. Okay, so it has atomic number 11. That means proton is 11. Atomic weight or atomic mass number is 22.999. So it can be easily round up to 23. Well, unless you are specifying what's the mass number of this isotope of sodium, okay. Otherwise, we would use the number from the period table. So you can see number of electrons is going to be 11. Neutron is going to be 23 minus 11 equals to 12. Okay, since proton neutron adds up 23. Now the atomic diagram for sodium will look like this. There's a little circle representing the nucleus. Inside this nucleus, there are 11 protons. So I'm putting a plus symbol with 11. There are 12 neutrons, a little circle followed by 12. And there are 11 electrons. Okay, so these 11 electrons has to go in the order of from inner layer to outer layer. So on the first layer, you would have up to 2 electrons. On the second layer, you can have up to 8 electrons. So far, that's 2 plus 8, 10 electrons. But you need to make up to 11 electrons. So on the third layer, you will have only 1 electron. Even though you could have more, but you don't. Okay, sodium has only 11 electrons. So this is the atomic diagram for sodium. And of course, the most important thing is you have to figure out the number of each particles, like 11 neutrons, 11 protons, 12 neutrons, 11 electrons. And also you have to follow this pattern here. You have to follow this pattern here to give us number on each layer, starting from inner layer to middle to the most outer layer. Okay, make up to number, whatever the number of electrons you have. Okay, all right, so let's look at another one. Let's look at the chlorine here. Okay, chlorine has symbol Cl. Proton, which is also the atomic number, is 17. The mass number down here is hard to see, but I can tell you the mass weight or is 35.5. Okay, now that means either 35 or 36 will be good enough. Okay, so let's say 36. So because of that, so the electron will be 17 as well, the same as proton, and the neutron is going to be 36 minus 17, which equals to 19. Okay, now we figured out all the numbers here, so let's draw out the atomic diagram of chlorine, which is a little circle with 17 protons and 19 neutrons. You can see neutrons and protons, they don't have to be exact the same number. Okay, some of them will be the same, but like these two cases, they're not. Okay, and you have total 17 electrons. 17 electrons, that means the first layer you're gonna have 2 electrons, second layer you're gonna have 8 electrons. Okay, and the third layer you can have up to 8 electrons. But there are already 10. Subtract 10 from 17 total, you would have only 7 electrons from for the third layer. Okay, so you can see chlorine has 3 layers of electrons, just like sodium. Okay, the difference is the chlorine has 7 electrons at the end, sodium has only 1 electron at the end. Okay, so different number of electrons, makes them different elements, which also make them into different property of the elements. Okay, so this is how you draw the atomic diagram. Feel free to practice this with all of these elements: sodium, lithium, sodium oxygen, neon, all of these. Okay, as a matter of fact, you may feel free to practice this by yourself, going through the 20 elements anyway. Okay, so the most important thing, like I said, I can't overdress this. Okay, remember this pattern from inner layer to outer layer 2882. Okay.